Hello. Now we are doing a simulating program for transient analysis. Now here we know the formula for we know the formula that m into d square delta by dt square, which is equals to pm minus pe. Now here there are four terms. If you see, that is m, then next is delta, and the thing pm and pe. Okay, now first we are going to do pe. For that pe, let's click on constants, take a constant button, name it as pe. P sorry, now let's do pm. Sorry, let's do pm. It is given that pm is 0.9. Press ok and it will be set. Then the next is that is pm minus pe, right? So we need a subtractor for that. So in the search option, search for subtractor, search for subtract. You'll get the option subtract, drag and drop it, and connect this pm to the plus terminal. Okay, the pe comes at the last, so hence you keep the minus terminal as it is. And next, the thing is, next thing what do we need is gain. We are gain using for m terminal, that is mass m. So m, so we in the search option you put gain, gain, gain. We'll get a gain, drag and drop it, and change the gain to 3.14, that is nothing but pi into 50 divided by 2.52 and press ok. Okay, and you can change this gain name as m. Next, connect this subtractor to gain m. Okay, as we know, you should place two integrators, because you have d square t divided by dt square. That's why search for integrator. You get an integrator. It's showing 1 by s, right? Choose that integrator. You need two of this, so take two of this. Okay, then double click on it, and the initial condition should be 21.64 into pi divided by 180. Do this for the other integrator also. 21.64 star pi divided by 180. Okay, now join these two in series. Okay, next, after the integrator you get now for the PE value you have a formula, that is nothing but EV by X into sine delta. Now you need delta as an input. Now from the output you are getting from this second integrator is nothing but delta. So you are taking that delta and you are giving it to sine to get sine delta. So in the search option, you won't get it in search option actually. Okay, then here you go for math operations. Click on the math operations. You get sine. Search for the sine here. That's somewhere here. Math function. See, trigonometric function sine. Drag and drop this. Okay. Then put sine here. Nothing but sine. Keep it as it is. And then you need a product for that. See, what is the formula for PE? It's nothing but E into V divided by X into sine delta. You got sine, and the output from this second integrator is nothing but delta. Okay, so you need to product both sine delta, E and V. Okay, then first search for the product here. You get this product. Okay, so double click on it. Actually we need 3 inputs, so press 3 and press OK. Design as you like. Okay, and one signal is nothing but sine deltas, and next you need E and V. For that you need constant terms. Search for constant. You need 2 of those, so take 2 of those and drag and drop it. Give it to one connection and another to another connection. The first one you can change the value as 1.1, which is already given in the question. That is nothing but E. So change this constant to E, and then this is nothing but 1. It's given, the V is nothing but 1, so keep this as V. So okay, you have kept this already as V now. Now this should be producted with 1 by X, right? So what is 1 by X? X is nothing but the impedance of the pre-fault and the during fault. You need to calculate the manual calculations, and you need to find out the pre-fault and the during fault. So what to do is you search the option called switch. It's named the switch. So the first option you get it, drag and drop it 1, then make the designs as you like. Okay, set, and take 2 constants. Actually you can copy these constants, but it's alright. Put for search constant, you get a constant. You need 2 constants here for reactance during fault and reactance post fault. Okay, first change this to post fault reactance is nothing but XPF. Then this you change it as XDF. This is nothing but during fault. Okay, the post fault is nothing but after the fault. The reactance at that time of the fault is nothing but 0.55, and press enter. Get this, and for the XDF, the during fault the reactance is nothing but 1.25. Press enter. It will be done and connected. Pre-fault should be connected at the top, and the during fault should be connected here. And then search for the clock. The first clock what you get is that, and then hold on. Okay, the clock what you get is this, and the next is, see, these terms you get sine delta E, sine delta into E into V. So what you get is nothing but X. So you need 1 by X. So you get that 1 by X near the math operations. Wait a second. Sorry guys, you don't get the reciprocal like that. So do the X reciprocal. So search here for math function. Now you get this e power u, right? Drag and drop it. Double click on it and change this exp to reciprocal and press OK. you'll get this, so that you think if you connect this, it will be converted to 1 by 1 by x. That's it. Okay, now you should do a product. So you can take this, Control C, Control V, you can copy it, you will get that. You need only 2 inputs here, you can place it as 2, and then the product of the one, this thing and this thing comes here. Now the final thing what you get is PE. You know the PE here you are left on, so place a PE here. Okay, you can design it as you like. This looks good, that's why I'm doing like this. Okay, it's time to place the, you need to know, get the output from the delta part. So take a gain, okay, press gain here, set the gain, we'll get a gain and a scope. The first scope, okay. Take this gain and attach the scope, and the input of the gain will be output from the second integrator, that is nothing but the delta value. So you have to change the gain of this actually to convert from the radians to degrees. That you need to put it nothing but 180 into 180 by pi. That is how you convert from radians to degrees. Click on OK and set this time as 0.5. This is enough. Okay. If you want, you can save it or however you want. And click on scope, maximize it, and you can actually change. You should change the settings. Settings, history, save data to workspace, and then save data, structure with time, and we should press apply, and then go for the style. Change everything like this. This is white, and this is black. This is the thickness of the what you get. This is black. Apply and okay. Okay, now close this. Now you run this program. And it's asking some access. I know it. So after running this program, you can see the scope. If you don't get this wave, you just do this. What's that? It's showing auto scale, right? Just do auto scale. You get a nice, beautiful waveform, and this is a waveform of this post fault and during the fault. Okay. This is all, folks. This is all how you do it for this thing. And now for if you want to do this thing, what is that? Only for the during fault. If you want to do only for the during fault, now just let me say you take this, Control C, Control V, take this, and actually cut this connection, delete this connection, and give this connection to here. Right. After giving this connection, you run. Now click on the scope, and you can't see the full wave, right? Just auto scale it, and you get like this waveform. This is where you get for during the fault. Okay, that's all, guys. Thank you.